Have you ever imagined what it would be like to travel to the stars? I mean, really think about it. What if you could take a trip for just a few years, but when you return to Earth, centuries had passed? Now, this isn't some plot from a sci-fi movie. It's a fundamental and honestly a pretty mind-bending law of our universe. It's a reality woven right into the fabric of space-time. So how on earth does this actually work?
Well, this brings us to one of the most famous puzzles in all of physics, the twin paradox. So picture this. You have two identical twins. One stays home, just living a normal life. The other, though, hops on a spaceship and rockets off close to the speed of light. Now, for the twin on the ship, everything feels totally normal. But for the twin back on Earth, if they could somehow watch, they'd see something absolutely extraordinary. Solving this puzzle? Well, it completely changes how we have to think about time itself.
So how do we start to unravel this mystery? It all comes down to one single, absolute, unbreakable rule. A speed limit that the entire cosmos has to obey. Once you grasp this one constant, you have the key to understanding why one twin comes back to a future they never could have imagined. This is the one rule that changes everything.
Okay, so in our everyday lives, speeds just add up, right? If you're on a train going 100 kilometers per hour and you throw a ball forward at 10, that ball is now moving at 110 relative to the ground. Simple enough. But light just doesn't play by those rules. The speed of light is always the same, for everyone. It doesn't matter how fast you're moving towards it or away from it. It's the one thing that is totally, completely constant in a universe full of variables.
This really strange, unshakable property of light is exactly what Albert Einstein called his second postulate. And it's pretty much the bedrock of his theory of special relativity. It's a fundamental law of the universe. The speed of light is the same for you, for me, for an astronaut zipping past Earth, for everyone everywhere, all the time. Nothing you can do will ever change how fast you measure it.
Right, so here's where it gets really interesting. If the speed of light is the one thing that absolutely cannot change, but moving around changes our perspective on, say, distance, then something else in the universe has to give. Something has to stretch or shrink to make sure that cosmic speed limit is never broken. And that something is time itself.
To really get this, let's imagine a perfect clock. But instead of gears, it uses light. Inside a box, you've got a little pulse of light bouncing between two mirrors. Tick, tock. If you're holding the box, you see that light travel a simple straight path up and down. The distance is fixed, the speed of light is fixed, so each tick takes a very predictable amount of time. Easy peasy.
But now, what happens if that box starts moving really, really fast? For someone standing still, watching it fly by, that light pulse isn't traveling a short vertical path anymore. To get from the bottom mirror to the top one, it now has to travel a much longer diagonal path. But remember the big rule. The speed of light has to be the same for the person watching too. So if the light travels a longer distance at the exact same speed, it must take more time to make the trip. From the outside, that moving clock literally appears to be ticking slower. And this incredible effect has a name: time dilation. It's all captured perfectly in this famous equation. Now, don't worry, you don't need to be a math genius to get it. All this is really saying is that as your velocity, that's the u, gets closer and closer to the speed of light, which is c, the time you experience slows way down compared to someone who's standing still. Put simply, the faster you move through space, the slower you move through time.
So, you might be thinking, okay, this is some pretty cool abstract physics that only matters if you're in a spaceship. But here's the thing. The effects of time dilation are not only real, they are absolutely crucial for a piece of tech you probably use every single day.
I'm talking about the GPS in your phone or your car. It relies on a whole network of satellites, and each one of them is orbiting Earth at a blistering 14,000 kilometers per hour. That incredible speed means the super precise clocks on board those satellites are actually experiencing time dilation. Their time is literally ticking at a different rate than our time down here on the ground.
And here's where it gets even crazier. It's not just one, but two of Einstein's theories at play here. Because the satellites are moving so fast, special relativity says their clocks tick about 7 microseconds slower each day than ours. But wait, Einstein's general relativity also says gravity affects time. And since the satellites are in a weaker gravitational field way up there, their clocks actually tick about 45 microseconds faster. You put it all together, and the satellite clocks get ahead of ours by about 38 microseconds every single day. If engineers didn't correct for that tiny difference, your GPS would be off by 10 kilometers every single day.
So, what do the twin paradox and the GPS in your pocket both tell us? They point to the same, frankly world-altering conclusion. That gut feeling we all have, that time is this universal river flowing at the same rate for everybody, everywhere, is just fundamentally wrong.
So to finally answer the question, who aged faster, the twin who stayed on Earth? The truth is, time isn't some big cosmic metronome. It's personal. Your experience of time is completely unique to your journey through the universe. For our traveling twin, their incredible speed through space meant they simply moved more slowly through time. It didn't stop for them, it just passed differently.
So I'll leave you with this final thought. If something as fundamental as the flow of time can actually stretch and shrink depending on how you look at it, what other core aspects of our reality are just waiting for us to see them in a whole new way?